For decades, scientists have been searching for one thing: not aliens, not new galaxies, not even habitable planets. Water. Liquid water. The one ingredient we know for certain makes life possible. And in December 2024, the James Webb Space Telescope finally found it. On a planet just 26 light-years away, water exists in liquid form. Not ice, not vapor. Liquid. But here's what nobody's talking about. This discovery changes everything we thought we knew about where to look for life. Since the first exoplanet was confirmed in 1992, we've found over 5,600 planets beyond our solar system. But finding planets is the easy part. Finding planets that could support life? That's where it gets complicated. Scientists have been looking for what they call the Goldilocks zone. Not too hot, not too cold. Just right for liquid water to exist. Earth sits perfectly in the sun's Goldilocks zone. Venus, just a bit closer, became a hellscape with surface temperatures hot enough to melt lead. Mars, just a bit farther out, lost most of its atmosphere and became a frozen desert. For years, scientists assumed we'd find liquid water on planets similar to Earth. Rocky planets, similar size, similar distance from their star. Then the James Webb Space Telescope launched on Christmas Day 2021, and everything changed. Unlike previous telescopes, Webb can see in infrared. It can analyze the atmospheres of distant planets by studying the light passing through them as they transit in front of their star. And in late 2024, while analyzing a planet called K2-18b, Webb's instruments picked up something nobody expected. But to understand why this discovery is so wild, you need to know what makes K2-18b completely different from Earth. K2-18b is nothing like Earth. For starters, it's 8.6 times more massive than Earth. It orbits a red dwarf star called K2-18, which is smaller and cooler than our Sun. And here's where it gets weird. K2-18b sits in its star's habitable zone, but it completes a full orbit in just 33 days. Think about that for a second. A full year on K2-18b is just over a month. But the planet's composition is what really threw scientists for a loop. K2-18b isn't a rocky planet like Earth. It's what's called a sub-Neptune, or mini-Neptune. Bigger than Earth, smaller than Neptune. And scientists think it might have a thick, hydrogen-rich atmosphere sitting on top of an ocean world. A completely different type of planet than anything in our solar system. Not a gas giant like Jupiter. Not a rock like Earth. Something in between. For years, scientists debated whether sub-Neptunes could even have liquid water. The hydrogen atmosphere would create crushing pressure. The planet's gravity would be intense. The radiation from the red dwarf star could strip away any water vapor. Most researchers assumed these planets were dead ends. Too weird, too hostile, not worth the search for life. Then Webb pointed its instruments at K2-18b. The telescope observed the planet as it passed in front of its star, analyzing the light filtering through the atmosphere. And the data showed something unmistakable. Carbon dioxide, methane, water vapor. But it wasn't just water vapor in the clouds. The combination of chemicals, the atmospheric pressure, the temperature readings, everything pointed to one conclusion. Somewhere beneath that thick hydrogen atmosphere, there's an ocean. A massive planet-wide ocean, with liquid water. The research team, led by Professor Nikku Madhusudan from the University of Cambridge, published their findings in the Astrophysical Journal Letters in December 2024. But what exactly did they find? First, the spectroscopy revealed methane and carbon dioxide in significant quantities. That by itself isn't unusual for exoplanets. But here's where it gets interesting. The ratio of methane to carbon dioxide was all wrong for a planet without liquid water. On planets without oceans, you'd expect to see way more carbon dioxide than methane. But on K2-18b, the methane levels were unusually high. The only explanation that fits the data? A liquid water ocean beneath the atmosphere, actively interacting with the hydrogen above it, creating methane through chemical processes. But the smoking gun came from something else. something called dimethyl sulfide, or DMS. On Earth, DMS is only produced by life, specifically by phytoplankton in our oceans. It's a waste product of marine microorganisms. And Webb's instruments detected potential signatures of DMS in K2-18b's atmosphere. Now, before anyone gets too excited, the DMS detection is tentative. It needs to be confirmed with more observations. The signal isn't as strong as the water and methane signatures. But if confirmed, it would be the first potential biosignature detected on an exoplanet. The first real hint that we're not alone. The research team is careful not to claim they've found life. What they're saying is this: K2-18b has liquid water, the chemical conditions for life as we know it, and possibly, maybe, the chemical fingerprints of biological activity. Other teams are already lining up to point Webb at K2-18b again, to confirm the DMS signature, to search for other biosignatures, to map the atmosphere in even greater detail. But regardless of whether life exists on K2-18b, the water discovery alone changes the game. Because if liquid water can exist on this bizarre sub-Neptune world, then the number of potentially habitable planets in the universe just multiplied exponentially. Before this discovery, scientists were focused almost entirely on rocky, Earth-like planets. There are roughly 300 million potentially habitable Earth-like planets in our galaxy alone, according to estimates from Kepler mission data. But sub-Neptunes? There are way more of them. In fact, sub-Neptunes are the most common type of planet we've discovered. They're everywhere, and we've been ignoring them because we assumed they couldn't support life. If K2-18b's ocean is confirmed, it means we've been looking in the wrong places. Or rather, we've been limiting our search too much. Think about what this means. Planets that we dismissed as too big, too gassy, or too weird might actually be ocean worlds teeming with the ingredients for life. The habitable zone just got a lot bigger and a lot weirder. But there's a problem. Life on K2-18b, if it exists, would be nothing like life on Earth's surface. The pressure would be immense, the darkness near total. The hydrogen atmosphere would create chemistry we've never encountered. Any life there would be adapted to conditions we can barely imagine. It wouldn't be little green men. It wouldn't even be fish or plants as we know them. It would be more like Earth's extremophiles, microorganisms that thrive in volcanic vents, in toxic waste, in solid rock miles underground, life that found a way in the most hostile environments imaginable. The question isn't whether K2-18b is pleasant for humans. It's whether life can exist in places we previously wrote off as impossible. And if the answer is yes, then the odds of finding life elsewhere in the universe just went way, way up. Some scientists are now recalculating the Drake equation, the famous formula for estimating intelligent civilizations in our galaxy. The inclusion of sub-Neptune ocean worlds as potentially habitable could increase the estimate by an order of magnitude or more, from hundreds of potential civilizations to thousands, maybe more. But here's the thing. K2-18b is just 26 light-years away. In cosmic terms, that's our backyard. If there's liquid water this close, on a planet type we barely started studying. What else is out there? The James Webb Space Telescope isn't done with K2-18b. Multiple research teams have already secured observation time in 2025 to study the planet in greater detail. The main goals are straightforward. Confirm the DMS signature. Search for oxygen. Look for other potential biosignatures like ammonia or phosphine. But beyond K2-18b, the discovery has triggered a gold rush. There are dozens of other sub-Neptune exoplanets in the habitable zones of their stars, all within observable range of Webb. Planets that we ignored before because we assumed they were just failed gas giants. Now they're priority targets. The European Space Agency is already planning future missions specifically designed to study ocean worlds, not just around other stars, but in our own solar system too. Because if K2-18b taught us anything, it's that oceans can exist in the strangest places. Europa, one of Jupiter's moons, has a subsurface ocean beneath its ice shell. Enceladus, a moon of Saturn, shoots water geysers into space from an underground sea. And now we know that planets 8 times Earth's mass, with thick hydrogen atmospheres, might be hiding planet-wide oceans beneath the clouds. The search for life is no longer limited to planets that look like Earth. It now includes worlds that look like nothing we've ever seen. And with each new telescope, each new discovery, the universe reveals that it's far stranger and far more full of possibilities than we ever imagined. We've spent decades asking if we're alone in the universe. The discovery of liquid water on K2-18b doesn't answer that question. Not yet. But it tells us where to look. And it tells us that the universe is more creative than we gave it credit for. Life doesn't need an Earth clone to exist. It just needs water, chemistry, and time. And now we know that all three might exist on worlds we never thought to check. 26 light-years away, beneath a sky thick with hydrogen, there's an ocean. What swims in it? We don't know yet. But for the first time, we're looking.